enzymes can actually be used in industries. We can also apply the knowledge or enzymes in producing useful things like we use in our homes or even industries. So we have some examples that we can talk about. We can have enzymes be used to make what you call biological washing powder. So this means that you have enzymes that can help in breaking dirt or organic matter that we can have on our clothes more easily compared to ordinary detergents. That's one application. The second application is that we know about plastics. Plastics are polymers, and these plastics are iterative polymers basically. And this means that they cannot be degraded. So they are non-biodegradable. Okay, so then that means that they will always remain in the environment for a longer time. But enzymes can actually be made to speed up this degradation. Okay, so that means that, for example, the peptides enzyme that can break down plastics. And then we can also use enzymes in industries again in making juices. So if we make juices from, let us say, fruits, uh, these fruits have cell that is actually very hard to digest. But when we have enzymes, they can actually break down these cell walls and ensure that we produce more juice from the fruits that we have. And then the last application that I can talk about enzymes is the use of enzymes in production lactose, which is basically milk production milk. So the enzyme that we use in making this lactose is lactase enzyme. Okay, so we look at some questions that relate to that concept. So we have a detergent company that uses protease and lipase enzymes in their washing powders. These enzymes break down protein and fat stains on clothes at low temperature. Okay, it's exactly what we have just explained. Now, the question is, why is it beneficial to use either using detergents at low temperatures? And the reason here is that at low temperatures, and that means that you don't need to warm up the water, and that saves money, basically money for energy, because you don't need to heat the water for you to use that detergent. Okay, so the detergent will work well even with ordinary water to use it in your clothes. Okay, and what would happen if the washing machine was set at a higher temperature of 80 degrees centigrade? The enzyme would technically get ignited and it would not basically work as expected. The next question that we can attempt, that you have a fruit production industry where enzymes like pectinases are being used to break down the cell walls and increase the release of oils from the fruits. The question is, what is the advantages? The advantage of using pectinase enzyme. The answer is simply straightforward, like this enzyme helps it break down the cell wall, and that makes it possible to release oils. And the company stops using the enzyme and notices low production yield in terms of and notices a low production of juice. Can you explain why that's happening? Of course, when you don't have an enzyme, it means that the rate of reaction of people, and that means that you not get more juice, because remember the enzyme breaks down the cell works effect. What we term as enzymatic inhibition. The meaning of this is that enzymes can be inhibited. That means that they will have different molecules that can prevent the action of enzymes, and that is what we mean by inhibition. So we basically have two types of enzymatic inhibition: competitive inhibition and the non-competitive inhibition. But of course, we shall look at other forms, for example, allosteric inhibition, and then we shall also look at end product inhibition. So therefore, you should be aware of these four forms of enzymatic inhibition. So then let's start with the first part, competitive inhibition. What you have is that the inhibitor, which is the molecule which is preventing the enzymatic action, now goes and occupies the active site of the enzyme, and that means that the enzyme will not be able to work. Okay, and then the non-competitive inhibitor, this one will attach to another part other than the active site, and they will inhibit the enzymatic activity. And then now we move to the other sites of inhibition. Allosteric inhibition is where you have another molecule attaching to the enzyme at another part other than the active site. But again, after attaching to that other, it causes the change in configuration of the enzyme tip site. Therefore, the enzyme will not be able to work anymore. And then we look at the last one, which is the end product inhibition, which is that when you form much of the product will basically inhibit further action of the enzyme that you don't produce more of the product. So it acts like a negative feedback mechanism. Okay, so those are the forms of inhibition that we can have. So let's look and take questions here and see if we can be able to answer it. So a research team is studying an enzyme, and that enzyme is succinic dehydrogenase enzyme. They find that malonic acid is a molecule that is structured similar to succinate and reduces the enzyme's activity. So what I called inhibition do we have here? The enzyme succinic dehydrogenase, what does it do? It basically, by that name, it suggests that it works on the substrate succinate. So if you have another molecule that looks like succinate, means that it can occupy the active site of that enzyme because it has the exact shape like that, the substrate. And that means that is competitive inhibition. Okay, so definitely if you have the competitive inhibitor, that means that the rate of reaction definitely decrease. So how could the researchers reduce the effect of malonic acid? Because remember, malonic acid is the competitive inhibitor. Okay, so what would the researchers do to make sure that the effect of malonic acid is basically reduced? They increase the concentration of succinate. If they increase the concentration of succinate, the impact of malonic acid will actually be reduced. So this brings us to a concept that if you increase the concentration of the substrate, when you have a competitive inhibitor, you are likely going to increase the rate of reaction. But not happen for the case of non-competitive inhibitors, because of the non-competitive inhibitors, they're not interested in the active site. So you go to question number 2. In a laboratory experiment, cyanide is found to inhibit enzyme that is involved in respiration by binding to a side other than the active site, changing the enzyme's shape. Okay. So what type of inhibition is this? Other than the active site, that is competitive, non-competitive, that is not competitive inhibition. And why can the inhibition be overcome by adding more substrate? It means since it is a non-competitive inhibitor, in the near future increase the secretion, the substrate it will regulate the reaction because the non-competitive inhibitor is not interested in the active site. Okay. And then we come to another concept. We have two drugs. Two drugs are being tested. Drug A binds weakly and discharges after like restoring the enzyme's activity. And then we have another drug that forms a permanent bond with the enzyme stopping its function. What are the types of weak inhibition that we are talking about here? Two drugs are being investigated. Drug A attaches to the to the enzyme temporarily. Okay, it bonds and then discharges temporarily. And then for drug B, it binds and completely remains bonded permanently. So the type of inhibition that we are having here is that since drug A attaches and then discharges, that means that it is the reverse co-inhibition. The only permanently attaches and doesn't discharge is permanent inhibition. So in the metabolic pathway, product Z binds to and inhibits enzyme A at the start of the pathway. What type of regulation is this? So you have the product inhibiting the enzyme, but is any product inhibition. Okay, so it is a negative feedback mechanism in a way and prevents the overproduction of the product.